So let's talk about a treatment you've probably heard about, especially if you follow sports: platelet-rich plasma, or PRP. You hear these stories of incredible recoveries. But what's the real deal behind it all? Is it just a bunch of hype, or is there some real healing power locked away in our own blood? Well, let's dive in and find out.
I mean, think about it. Whenever a superstar athlete, like a Tiger Woods or a Rafael Nadal, gets a really tough injury, you almost always hear whispers about this special treatment. They're using their own blood to get back in the game faster. It seems to be the go-to for everything from torn muscles to that nagging tendon pain. So what is going on here? What's the science behind this thing?
And just to be clear, this is not some new fad. For more than a decade now, the buzz around PRP has just been getting louder and louder, mostly fueled by these amazing success stories you see in the media. But for a long time, the hype was way ahead of the actual scientific proof. It was called a miracle cure, but was it really?
Okay, so before we can even begin to talk about whether it works, we have to understand what it is. We need to get into the nuts and bolts of this so-called healing engine. What are they actually putting in that syringe?
At its core, the idea is actually pretty simple. You take a person's own blood, and you concentrate the platelets. Now, these are the tiny cell fragments that are famous for clotting a cut, but their real superpower is that they release a ton of growth factors. The whole point of PRP is to create this super concentrated dose of all those healing powerhouses.
Here's a great way to picture it. Imagine your body's healing process is like a big construction project. Your platelets? They're the specialized construction crew that immediately rushes to the site of the damage. What PRP does is it takes that entire crew, basically multiplies its size, and then airdrops them directly onto the most critical part of the job.
And this slide shows you the exact tools that construction crew brings to the job. See, platelets are just jam-packed with these things called growth factors, and each one has a very specific role. You've got PDGF, which is like the foreman, recruiting other cells. TGF-beta is like the architect, laying down the scaffolding for new tissue. Then you have VEGF, helping with blood supply, and IGF-1, building up protein and bone. It's a whole team of specialists, all working together.
So how do we actually create this super concentrated healing crew? You might be thinking it's some complex, high-tech process, but it's actually surprisingly straightforward. Let's walk through it.
It all starts with a simple blood draw, just like any other. Then comes the really cool part, the centrifuge. This machine spins the blood super fast, which separates everything into layers. The heavy red blood cells sink to the bottom, and you're left with this golden layer of platelet-rich plasma right on top. That's the good stuff. It's carefully pulled out and then injected right back into the injured area, usually with an ultrasound to make sure it gets to the exact right spot. Okay, so we know what it is, we know how it's made, but now for the million-dollar question. Does this stuff actually work? This, my friends, is where the story gets really interesting. It's where all that hype smacks right into scientific reality.
Let's just rewind back to 2010 for a second. The International Olympic Committee got a bunch of experts together to look at PRP, and their conclusion was, well, it was a real wake-up call. They found that even though it was super popular, there was a shocking lack of good, solid science to back it all up. For years, the science was just playing catch-up to the hype. And this slide just lays out the problem perfectly. On the left, you've got this incredible promise we saw in lab studies, all those growth factors doing their thing. But on the right, you had the messy reality back in 2010. Not enough good human trials, studies that contradicted each other, no standard way to even prepare the stuff, just a lot of big, unanswered questions.
But the story doesn't end in 2010. Not at all. In the years since, researchers have been working like crazy, and now we have a much, much clearer picture. So let's fast forward to today and look at a really solid case study that's shedding some serious new light on all this.
A big study out of the UK gives us exactly the kind of long-term data we've been waiting for. And they focused on a really tough, stubborn problem: chronic tennis or golfer's elbow that just wasn't getting better with anything else. I mean, this is the perfect kind of test for PRP.
And the results are pretty striking. Get this, 2/3 of these patients, people who had been dealing with this pain for months, saw a really significant improvement. We're talking less pain and actually being able to use their arm again. So for the clear majority of people in this study, PRP made a real tangible difference in their lives.
And it's not just about the clinical results. They also looked at the cost. And wow, the numbers are just staggering. The PRP treatment pathway costs just over £500. The alternative? Surgery at almost £3,000. That is more than 5 times as expensive. This shows that PRP could be a massive game changer for healthcare systems, not just patients.
And here is the real kicker. Only 6%, Just 6% of the patients who got the PRP treatment ended up needing to go on and have surgery anyway. This tells us that PRP isn't just another treatment, it's a powerful way to potentially avoid much more invasive and expensive procedures down the line.
All right, we've looked at the hype, we've gone through the science, and we've seen the latest evidence. So what's the final verdict here? Let's put all the pieces of the puzzle together.
So what have we learned? Well, first off, PRP is not some magic bullet that cures everything. Its effectiveness really depends on the specific injury and how the PRP itself is prepared. But, and this is a big but, for certain chronic issues like that tennis elbow, the evidence is finally clear. It is a totally valid, cost-effective option that can seriously help people avoid surgery. The science is finally catching up to the hype, and it's painting a really promising picture.
You know, the story of PRP is a really cool look at how medicine actually works. It moves from that initial hype to cautious hope, and finally to real evidence-based healing. The question isn't really if it works anymore, but where it works best and for whom. And now that we're seeing it conquer these tough tendon injuries, you have to wonder, what's next? What problem will this incredible therapy solve next?